I'm live, and this is Math 40 Elementary Algebra, Chapter 7.4, Adding and Subtracting Rational Expressions with Unlike Denominators. So in other words, I want to add 1/2 plus 1/3, and I don't know what it is. So if we have unlike or different denominators, or we don't have common denominators. I don't know if they're called uncommon denominators. That would be pretty cool, but I doubt it. So we have to come up with a way to combine these two. Now, if I said I have one puppy and one cat and I add them together, do I have two puppies or two cats? And the answer is no. So it's I can't draw a puppy. I could draw a spider. I'll leave that off because I've been told the spiders just scare everyone. Yay! Every time a math student gives up the will to live, I get a toaster. Yay! Okay. So let's talk about a couple of phrases. LCM stands for least. That means smallest. Common means it's shared. Multiple. That's the bigger number they go into. I know multiples and factors are always hard to keep track of. So multiple means bigger numbers. LCD is the least common denominator. Now, an LCD specifically refers to fractions. An LCM can refer to fractions or other things. I don't have a preference. Some people do. As far as I'm concerned, when you're talking about fractions, you can use LCM and LCD interchangeably for what we're going to do. The other thing is that some people use the word lowest, which is interesting that least and lowest both start with L, which is kind of cool. Okay, so least common multiple, least common denominator. So if I have 1/2 plus 1/3, what is the easiest way to find a denominator that matches for both of them? A least common multiple or a least common denominator? You're right. So I'm going to say these don't match. But what you can do is you can take 2 times 3 and get 6. And then you can put them both in terms of 6. So what would we do? Well, for 1/2, notice when something gets scary, I start writing really big. It's actually a really surprisingly good technique. It's an interesting way to tell your brain, see, look, it's friendly. You can handle this. 1/2, and then I'm going to write sixths, and I'm going to say to myself, okay, how do I make a 2 into a 6? Well, there are a lot of ways to make a 2 into a 6, but if I'm using multiplication, I multiply by 3. Remember that fractions balance top to bottom, so I have to multiply by 3 on top as well, and I get 3/6. Okay, what about the 1/3? Same thing. If I want to convert to sixths, here I'm going to multiply by 2 top and bottom, so I get, oops, I did it in red. Oh my goodness. Don't tell anyone. Okay, so now I've got the old fractions. I've got new fractions. They have common denominators. See how that is? Ooh. So I can now take 3/6 and add 2/6 and get 3 plus 2 over 6, or 5/6. What do you guys think? Woohoo? Ready to do it for reals and have lots of fun and talk about dun dun dun. Shall we talk about pants math? Yay, pants math. Okay, so it is time for a puppet show. Back in the 80s and 90s, there was a book. I'm not sure when it was written. It's called The Sisterhood of the Traveling Pants, and it was made into a movie. And basically, it starred 4 beautiful young women, and they had a magical pair of pants. Now, I think magical pants are hilarious. And I also think denominators are kind of like the pants of the fraction. So I immediately fell in love with this idea. Full disclosure, I have never seen the movie nor have I read the book, which I think is important because I would probably become too enamored of it and then I wouldn't want to make fun of it anymore. And I'm not really making fun of it, but I do find the concept of magical pants to be hilarious. So these are magical pants. And what happens is that there's only one pair of magical pants. So each of the friends takes a week or a year. I don't know. Again, I've not seen the movie or read the book. And they take the pants and they put them on and they magically fit perfectly and they go on a great adventures and then they come back from the adventure and then they give the pants to the next person. So this amuses me greatly, the idea of magical traveling pants. Okay, so what I need are my stunt spiders. I've got 2 spiders here. As you can see, my 2 spiders are very different shapes, and that's okay. You know, all spiders are awesome. My pants are stuck, sorry. Ah, there we go. So, if I were going to make a pair of pants for this spider, the pair of pants would look a little, I'm going to have to move it down, sorry. Would look a little bit like this, right? Those are good pants for that spider. And then if I were going to make pants for this spider, the pants would look a little bit more like that. Oops, the pants are falling down. Although that is a style. This spider's going to wear the pants a little higher. There we go. Okay. So, the thing is that if we wanted a pair of pants that fit them both, neither of these pairs would work because this pair of pants would be altogether too short. This pair of pants would not be wide around enough in the middle. So what we need to do is we need to find a pair of pants which is both tall enough for the tall spider and wide enough for the wide spider. Now notice that these pants are too big around the middle. So what is this spider going to do? This spider is just going to wear a belt. Okay. And now these pants are way too long for this spider, but what can you do? You can roll up the bottoms, or as a short spider myself, the other thing you could do is wear shorts. So, you know, opt out of the whole pants thing. But then the whole point is doesn't gonna work. So what did I do to get my LCD? My LCD pants have all of the benefits of the wideness from the wide pants and all of the benefits of the tallness from the tall, oops, sorry, let's see, get it in. All the benefits of the tallness from the tall pants. So that's what we're looking for. We're looking for a pair of pants that will magically fit both spiders. Now, here's the important question. Do the 2 spiders have to wear the pants at the same time? And the answer is no. No, of course not. No, we're not going to put 2 spiders into a pair of pants. That's no. So what we're going to do is just make sure that the pants fit each spider. Okay, that's pants math. So if I've got these 4 rational expressions, I need to look at the denominators. I've got 6, which is 3 times 2. And I've got 4x, which is 2 times x. I've got 12x squared. And you may have to do a factor tree for this, and that's fine, but I'll tell you it's 3 times 2 times 2 times x times x. It's 3 times 4 to give me the 12. And then the last one is 2xy, which is 2 times x times y. So I've got a lot of things going on here. And the question is, what is the LCD or LCM, which you can use interchangeably, least common denominator, or the least common multiple of the denominators for these 4 rational expressions? And what you want to do when you're finding common denominators, you want to think of the most. And I know that's a weird phrase. It's like the most. What does that even mean? Well, for my least common denominator, I want to know the most number of threes. So for example, there's a 3 here and there's a 3 here. I don't need both of them though, because the spiders and the young women don't wear the pants at the same time. They wear them individually. So what's the most that 3 ever shows up? Well, 3 only ever shows up once, so we'll use 1 3. Now, what are these 2 spiders or young women going to do? Well, they're just going to put on a belt because they don't need the 3. It's okay. It's a little extra. What we're trying to do is come up with pants that fit everyone. And let's be honest, math is not magic. And math is logic. They sound similar, magic and logic, very close and in sound, but completely different concepts. So we're going to have to make these least common denominator, and there's going to be some extra. It's just the way it happens. So, okay, I've got an extra 3 for these 2, but I got to put it in for the top and the third one. Now look at the 2s. All together, I've got 1, 2, 3, 4, 5, 6. Do I need 6 2s? And the answer is no. No, they're not all going to wear the pants at the same time. That's ridiculous. Imagine 4 spiders in a pair of pants. This is starting to get just silly. So what the worst thing in the world would be silly, right? So what's the most number of times 2s showed up? There's 1 2 here. There's 1 2 here. There are 2 2s here and 1 2 2 2s. So we're going to put 2 2s in for this one, even though nobody else needs that, because this one, when you've been, it's, let's say you're bored at home and there's a bunch of donuts lying around, sometimes you have an extra 2 in the trunk. So, and then X's. What's the most number of X's? Well, I've got no X's, 1 X, 2 X's, and 1 X. I'm going to use 2 X's. That's the most. And then anybody else? And the answer is, yeah, this one has a Y. That's okay. We love everyone. Doesn't matter what your shape is. Doesn't matter what your size is. You are awesome. And you are a valid, wonderful person deserving of everything good in the universe. Unless it's something I want, in which case I would like it, please. But you can have everything else. Okay. 3 times 2 times 2 is 12. X squared y. Now here's the thing. You can always double check your common denominator. Do I see a 3 and a 2? I see a 3 and a 2. We're golden. 2 2x, 2 2x, 3 2 2xx, 3 2 2xx, 2xy, 2xy. They don't have to be next to each other because it's multiplication. All of these exist in here. Now, what if you make a mistake and your common denominator is too big? You put in extra stuff. That's fine. It just means you'll have more of a mess at the end to take care of. So like if you see if there's a mosquito flying around and you decide to get out a cannon and you take out the mosquito with the cannon, you're going to have to possibly rebuild a wall. You got rid of this mosquito, which was what was important, but there's a little bit of a mess. See, that's what you want to do. So we try to make this as small as possible to minimize the mess. Okay, are you ready? Woohoo! Now, after all this excitement, the very first problem we're going to practice on is going to feel kind of like a letdown. At least, I don't know, maybe it doesn't. 1 over x plus 1 over y. These are not common denominators. So we have to come up with some common denominators. So the LCD, now in this case, there's an X and a Y. After everything we did up above, an X and a Y, the LCD is just, you're right, it's X and Y. We got to take the most X's and the most Y's. So there's an X and a Y, we need them both. Okay, so what I'm going to do is I'm going to take this space right here and I'm going to use it to convert each of the old fractions into the new fraction. So I got a 1 over x and I got a 1 over y, and each of them has to be converted. So let's look at the x. This has an x already. It's missing a y, so let's check that in there. To keep it balanced, we'll write it on top as well, and then we'll get 1 times y or y. Now, right here, people get very tempted because they're like, oh, look at the y's, cancel the y's. Do not cancel the y's. You have intentionally fluffed this up. This is big and fluffy so that they will add. You want to do not reduce. have, you're going to have to hold yourself back. Do not reduce. Okay, here, I've got a y. I need an xy. I'm missing an x and a multiply by an x. So far, so good. Awesome. Let's go ahead and add them. We had 1 over x plus 1 over y. We now have y over xy plus x over xy. Common denominator is xy. And up top, I've got y plus x. Some people would rewrite it as x plus y over xy because, again, a lot of times we put things in alphabetical order when we can. It's just we can't help ourselves, It's part of the pact with the devil. Oh, I said too much. Okay, so the next thing is people are going to go, oh, look, I can cancel the x's. I can cancel the y's. Do not cancel 2 terms. If there's more than one term, if there's a plus or a minus, pluses and minuses hate you personally. So do not reduce this unless you can factor. Is there anything you can factor out of x plus y? If not, there's nothing common, you're done. Do not cancel. Don't fall for it. It's a trick. It's a trick. It's a trap. Don't go in the basement. Don't factor if there's more than one term. That would be a good, oh my gosh, I need to make a math horror movie. Okay, math on.